let's come to the new topic, greatest integer function. For any real x, the symbol box x denotes the greatest integer less than equals to x. मतलब किसी भी रियल x के लिए ये बॉक्स x होता है वो डिनोट करता है सबसे बड़ा इंटीजर उस x के पहले, ठीक है। मतलब कि कोई भी रियल वैल्यू हो उसके जस्ट पहले या उसके इक्वल्स इंटीजर उसका ग्रेटेस्ट इंटीजर फंक्शन होगा। लाइक सी एग्जांपल बॉक्स ऑफ 3.14। तो बॉक्स ऑफ 3.14 मतलब 3.14 तो छोटा और ग्रेटेस्ट इंटीजर मतलब 3.14 से छोटा सबसे बड़ा इंटीजर कौन हो सकता है? 3। सो बॉक्स ऑफ 3.14 इज 3 एंड बॉक्स ऑफ 3, तो बॉक्स ऑफ 3 इज आल्सो 3 क्योंकि ये तो खुद ही इंटीजर है। मतलब here we can see less than or equals to x. If x is integer then output is also integer. If x is non-integer then output is also integer, but we have to take here the greatest integer less than equals to x. Now let's see on the number line. This is the number line. Sorry, minus. Okay, so from -1 to 0, the value of greatest integer function is -1. From 0 to 1, the value of greatest integer function is 1, and from 1 to 2, the value of greatest integer function is 1. Sorry, here is 0. Because for this reason, the integer just less than this values is this. That means for any region like 1.4, 3.4 or 6.4, just preceding integer is the greatest integer function, and for negative integer we have to see that like take example of negative integer, negative values, box of -3.2. So as we can see many students can write as 3 -3, sorry, but it's not correct. Box of -3.12 is 4 -4, sorry, because here we can see box, assume this value is 0.5 -9. So box of -0.5 is -1 because the preceding integer of 0.5 is -1. So here the preceding integer of -3.2 is -4, not -3. Now we are moving further to the properties of greatest integer function. Let x and y be real number. Then we have x greater than box x and less than box x plus 1. Let's see. Here is number line. This is 0. This is 1. And this is -1. Let's assume x lies between 0 and 1. Then value of box x is 0 and the value of box x plus 1 is 1. So here from here we can see that x lies between 0 and 1 and value of whole range of x is 0, and for the value of x is 0, box x is also 0, so here equality also holds. And another one is box x which is greater than equals to x minus 1 and less than x. Here we can see this is the range of x and this is the value of box x. and the range of x minus 1 is this. This is the range of x minus 1, and this is x, and the value of box x is this. So from here we can see that box x lies between x minus 1 to x, and another one is box x minus x lies between 0 and 1. So we are moving back to this. X greater than equals to box x less than equals to box x plus 1. Now subtracting box x on this. So box x minus box x less than equals to x minus box x less than box x plus 1 minus box x. So this is cancelled here and this is also cancelled here. So from here we can see that box x minus box x greater than equals to 0 and less than 1. Let's see another property number 2. It is another definition of greatest integer function. For a real x, the count of integer between 1 and x is a greatest integer function. It means, for example, let x is 6.2. So box x is the count of integer between 1 to 6.2. So let's write here integer 1, 2, 3, 4, 5, 6. This integer lies between 1 to 6.2. So we have to count this integer. So this is 1, 2, 3, 4, 5 and 6. So this value is 6. And now moving forward to third property, box x plus m is equals to box x plus m if m is an integer. Let's see how. If m is an integer, then box x plus m is box x plus m. For example, let's see this example. X is 6.2 and let another m is 5. So box of 6.2 plus 5 is equals to box of 11.2. This is 11, and we can also write it as box of 6.2 plus box of 5, and box of 5 is 5. So we don't have to write box of 5 because it is an integer. So box of integer value is also integer. So box of 6.2 is 6 and plus 5, which is also 11. So both are same. Now moving to the next property. X minus box x is the fractional part of x, which is denoted by this fractional part of x. So from here we can see that x is box x plus fractional part of x. Let's see an example. Let x equals to 3.2. So box x is 3 and rest is fractional part of x. As from here we can see that fractional part of x is x minus box x. So fractional part of x is x minus box x. So 3.2 minus 3 is 0.2. and we can see here also as this is 3.2 and this is 3 and this is 0.2. Let's take another example. X equals to minus 3.2. So here and box of x is minus 4. So fractional part of x is minus 3.2 minus 4. So it is equals to 0.8. And for integer we can see that x is equals to box x. We see earlier that for integral part of x, box x is as same as x. So here fractional part is 0. For integral part, fractional part is 0. Let's see the range of fractional part of x. As we have discussed on the first property, x lies between box x plus 1. Now we are subtracting box x from this. So box x minus box x is then equals to x minus box x less than box x plus 1 minus box x. Here box x cancel and here box x cancel. And from here we can see that x minus box x is fractional part of x. So fractional part of x lies between 0 and 1. As we can see here, when we take example of positive integer, it comes between 0 and 1. When we take negative example, it also comes between 0 and 1. And when we take an integer, it's 0. Now we can see it on the number line as it's a line. This is the value of box x and this is box x plus 1 and here is value of x. So this is the value of x, and as we can see here, x minus box x is the fractional part of x. So this is the fractional part of x, because this minus this means x minus box x is the fractional part of x. Now I am going to discuss box of fractional part of x is 0 and box of minus of fractional part of x is 0 if x is an integer, otherwise it is minus 1. As we discussed earlier, fractional part of x is greater than or equals to 0 and less than 1. So any number lies between 0 and 1, its box part is always 0. So box of fractional part of x is equals to 0. And now I am going to multiply minus 1 into this. So 0 greater than or equals to minus fractional part of x greater than minus 1. As you can see here, when fractional part of when this part belongs to minus 1 to 0, then it gives minus 1. When x is integer, then this part is 0. Now moving to the next property, box x plus box of minus x is 0 if x is an integer, otherwise it is minus 1. As we discussed earlier, x is equals to box x plus fractional part of x. Now I am going to replace x by this. So we can write it as box x plus fractional part of x plus minus box x minus fractional part of x. As we discussed earlier, when integer is inside the box, then it comes outside as it is. So both of this box part is integer, so both comes outside of this box. So we can write it as box x plus box of rational part of x plus minus of box x, sorry, plus fractional part of x. Now this and this are cancelled, and as we discussed earlier, box of fractional part of x is 0, and so this is 0, so we left with box of minus fractional part of x. So this follows the property of box of minus of fractional part of x. Then this is an integer. When x is an integer, then this is 0 from here, so this is also 0, and when x is not an integer, then this is 1. From here we can see that this is also minus 1.